As quantum-safe algorithms emerge, your cryptography can't be frozen in time. In this topic, we'll look at how to design HSM-backed systems that can swap algorithms, migrate keys and certificates, and evolve securely without breaking your applications or your compliance posture. The quantum challenge starts with time. Our data often needs to stay confidential for years or decades, but today's cryptography might not last that long. Attackers understand this. They can intercept and store encrypted traffic now, then wait until quantum capabilities mature and break algorithms like RSA and ECC. This harvest now, decrypt later window is what forces us to plan our transition early, not at the last minute. Crypto-agility is the ability to change cryptographic algorithms, keys, and even entire protocols without breaking your applications. Instead of hard-coding "use RSA with this key forever," you design systems that treat crypto as a replaceable component behind an interface. That agility is what lets you handle post-quantum migration, respond to new vulnerabilities, and meet evolving standards, while avoiding downtime and large-scale code rewrites. Rigid crypto architectures tightly couple applications to specific HSM APIs and hard-code algorithms. That feels fast at first, but every change becomes a code change, a test cycle, and often downtime. In an agile architecture, applications simply request capabilities like sign this or encrypt that. Algorithm choice and key policies live in a centralized crypto engine. Decoupling like this lets you switch algorithms, update policies, or introduce post-quantum options with configuration changes, instead of refactoring application code. Abstraction layers are your main tool for achieving that agility. Instead of every application talking directly to a particular HSM or crypto library, they call a simple crypto service. Sign this document, wrap this key, establish this session. The service then decides which HSM or backend to use and how. This gives you freedom to mix on-prem, cloud, or different vendors, swap algorithms, or add quantum-safe options later, without touching business logic or breaking existing clients. Configuration-driven policy enforcement is the backbone of crypto agility. Rather than hard-coding algorithms in each application, you define a central crypto profile that lists allowed algorithms, modes, and boundaries such as FIPs only. Each application request is evaluated against that profile by a policy engine before the HSM does anything. If the policy changes, for example, you move to a quantum-safe hybrid suite, you update the profile once. All integrated systems immediately inherit the new rules, with a clear audit trail of what changed and when. As you plan for post-quantum cryptography, you can't just swap algorithms in software and hope it works. Your HSMs must actually handle larger keys, new parameter sets, and future firmware. So you assess three capabilities: which NIST post-quantum algorithms they will support, how flexible key templates and sizes are, and how easily firmware and deployment models can evolve over time. When NIST moves, you need a roadmap that moves with it. During the draft phase, your focus is experimentation. Enable test partitions, load beta libraries, and evaluate performance and interoperability. Once standards are finalized, you switch to controlled rollout, dual control approval, signed firmware updates, and clear backout plans. Before legacy algorithms are deprecated, all production keys, policies, and integrations must be migrated, and your HSMs revalidated for FIPS or common criteria so auditors can see exactly what was changed and when. Cryptographic agility isn't just a technical feature, it's a governance responsibility. You establish a central crypto board that decides which algorithms are allowed, how and when they're deprecated, and what good looks like across the organization. That guidance is captured in an enterprise crypto baseline document. Security and compliance define the rules, architecture encodes them into designs, and IT operations enforces them in running systems. When those three functions keep the baseline in sync, you avoid ad hoc crypto choices and chaotic migrations. Before you can go quantum safe, you must know exactly what you're protecting. A cryptographic inventory means discovering every place keys, certificates, and algorithms live, in HSMs, applications, databases, and cloud services. This is where you identify weak or legacy algorithms, long-lived keys, and business-critical dependencies. Without this map, any migration plan is guesswork. and likely unsafe. When planning quantum-safe migration, think in terms of risk versus effort. Start by protecting systems that are both high risk and relatively easy to change. Internet-facing VPNs and external TLS endpoints. Their prime harvest now decrypt later targets. Next, move to high-risk but complex areas like your core PKI. These need careful design, testing, and staged rollout. After that, address low-risk, low-complexity systems, and finally the difficult, low-risk legacy internals. This sequence keeps early effort focused where quantum impact is greatest. Hybrid cryptography is a transitional strategy where you keep today's classical algorithms but wrap them with post-quantum ones, like a double lock on the same door. An attacker now has to break both the classical layer and the post-quantum layer to succeed. This gives you two benefits at once: interoperability with existing systems and protocols, and immediate protection against harvest now, decrypt later attacks, even before you've fully migrated to pure post-quantum schemes. To keep crypto agile at scale, you want the entire lifecycle automated. Keys and certificates are issued via APIs and wired into CI/CD, so every new service or release gets what it needs without manual steps. Deployment pipelines push them out with consistent policies and naming conventions. Continuous monitoring watches for expiring, unused, or misconfigured keys. Rotation and revocation are then triggered automatically based on time, risk, or incidents, with detailed logs so you can prove control to auditors. Think of this roadmap as your playbook for moving from legacy and fragile to quantum safe and agile. First, discover and inventory. Build a reliable catalog of algorithms, keys, certificates, and HSM integrations. Next, add abstraction and governance, so applications call crypto services through stable interfaces controlled by clear policies. Then pilot hybrid models combining classical and PQC in low-risk areas to gain experience and confidence. Finally, phase in full PQC, guided by risk, regulation, and business priorities, using your agile architecture to evolve without disruption.